Hello, in this video we're going to go over this beautiful problem. It says consider n equally spaced points on a unit circle. Prove that the product of the n minus 1 distances from one of them to each of the rest is equal to n. For example, if you look at these 7 points that are equally spaced on a unit circle, the distance from 1 to 2 multiplied by the distance from 1 to 3 multiplied by the distance from 1 to 4 multiplied by the distance from 1 to 5, 1 to 6, and 1 to 7. These are 6 distances. They multiply to 7. Let's look at a couple of examples and then see how we can prove this one. For example, if you look at the unit circle and consider an equilateral triangle inside the unit circle, let's call that ABC. The product of AB and AC, so I don't need the BC in fact, the product of AB and AC would be 3. Okay, so first of all, each one of these is 120 degrees or 2 pi over 3. Let's evaluate AC and then multiply by itself because we know that AC and AB are the same. If you look at this angle is 2 pi over 3. AOC is 2 pi over 3. If we drop a perpendicular, we get the midpoint. So this angle would be pi over 3. AO is 1. The length of AO is 1, which means AM is going to be sine of pi over 3. Which means AC is 2 times sine of pi over 3. Sine of pi over 3 is root 3 over 2. Multiplied by 2, we get root 3. So the product of AB and AC would be root 3 squared, which is 3. So that checks with what we said. If you look at a square, what we have is equally spaced points on a circle, so 4 points. And we are looking at the distance from one of them to the other 3. This one is exactly 2 because the radius is 1. This is a 90-degree angle. This is 1. So this would be root 2. So 2 of these distances are root 2. This one and this one are root 2. And the third one is going to be 2. And this is going to be 4, and that also checks. Now let's look at what happens in general. So we have n points that are equally distanced on a unit circle. So what are the most convenient points on the unit circle that are equally distanced? Those are nth roots of unity. The first one is 1. The next one is e to the power of I 2 pi I over n, and so on. The next one is e to the power of 4 pi I over n. So if we look at the points 1, e to the power of 2 pi I over n, e to the power of 4 pi I over n, and in general, e to the power of 2 pi I k over n. The last one would be e to the power of 2 pi I n minus 1 over n. These are n points on the unit circle that are equally distanced. Let's find the distance between each one of them to 1. So let's look at the product of 1 minus e to the power of 2 pi I over n times k. K equals 1 to n minus 1. We are trying to prove that this is in fact equal to n. So that's the objective. Now if you look at these e to the power of 2 pi k I over n, for k equals 1 through n minus 1, z to the power of n would be e to the power of 2 pi ki, which is 1. So these are n minus 1 roots of unity. So if you consider z to the power of n minus 1, n minus 1 of these roots are these. The last one is in fact 1. So we can factor this one as z minus 1 times the product of z minus e to the power of 2 pi ki over n, and k ranges from 1 to n minus 1. Now we're looking to evaluate this one when z equals 1. So let's divide by z minus 1. So we get this is equal to the product k equals 1 to n minus 1 z minus e to the power of 2 pi ki over n. Now we are looking for the left hand side at z equals 1, but we cannot plug in 1. So instead what we're going to do is we're going to use difference of nth powers, and we're going to get z to the power of n minus 1, z and 1. So that means the equality becomes z to the power of n minus 1 plus z plus 1 equals the product of z minus e to the power of 2 pi ki over n, k equals 1 to n minus 1. Now we're going to substitute z equals 1. If we substitute z equals 1, we have n terms, all of them are 1, so we get n equals the product of 1 minus e to the power of 2 pi ki over n, k ranges from 1 to n. And what we needed was absolute value of these. So therefore the answer is in fact n. And that brings me to the end of this video. So I will see you in the next video.